So what we'll do is we will configure segment routing for first ISP1. ISP1 was basically running iOS XZ, and we will enable segment routing there. And then we will configure ISP2, which is basically running iOS XR, and we will configure segment routing there. We will not enable segment routing preferred over LDP. So we will first check out which one is being preferred by default, and then we will move segment routing to be preferred over LDP. So let's do this. So we will start off with ISP1. Let's quickly access our routers. So I have XZ router 2, and the first thing that I'm going to do on my XZ router 2 is basically activate MPLS. In fact, activate segment routing for MPLS data plane. So that's going to be done by the command segment routing, and let's hit enter. So segment routing, in fact, MPLS. So what this command does, it enables segment feature using the MPLS data plane. The next thing I would do is define the connected prefix SID. So if I look at the question mark here, I have very few options. So because I need to define as per the question, I need to define the prefix SID, which is going to be a unique global SID value for the router. I need to set that an absolute value. I could do an index value also, but because my question says that set an absolute value, we will do that. And that's basically done by going to connected prefix SID map. So I have some more options here. We'll look at that later. As of right now, let's go and say connected prefix SID map. And then I would go inside the address family. So address family IPv4, and here I can set the prefix SID value. So like I said, I could do this per an absolute value, or I could do it as per index. So let's say if I do 2.2.2.2, which is my loopback 0, my question says use the loopback 0 for the prefix SID. It's based on the loopback. So the loopback of router 2 is 2.2.2.2/32. So now I have two options. Either I set an absolute value or I set the index. So if I do index, let's say 2, and hit enter, this basically means that my prefix SID would be based on my global sRGB, which is 16,000 plus the index value, which means my prefix SID is going to be 16,002. I could do this, or I could set a unique absolute value by saying 2.2.2.2/32 and then absolute 16,002. Let's exit out. So that's the first thing that you would do. Enable segment routing MPLS, which basically enables the segment routing feature using MPLS data plane, and then define the prefix SID. Let's do this on all the routers. So XZ router 6, or in fact router 3. So segment routing MPLS, connected prefix SID map, address family IPv4, and then 3.3.3.3/32 absolute 16,003. Remember, it has to be unique. Let's exit out, and let's do the same thing on the remaining routers. So segment, let me just quickly copy paste. So we will copy up till here, go to XZ router 4, and give this as 4.4.4.4/32 absolute as 16,004. Then I have XZ router 5. And this would be 5555/32 absolute 16,005. And the last router for ISP1 is going to be XZ router 6. So again, enable segment routing, MPLS, connected prefix SID, address family IPv4, and then 6666/32, absolute 16006. So now I have configured, I've enabled segment routing feature using MPLS data plane. The next step would be to enable segment routing for IPv4 control plane and segment routing MPLS data plane within the IGP. So the IGP which we were running for ISP1 was OSPF. So for that, I would have to go to router OSPF1 and say segment routing MPLS. So enable segment routing MPLS. And that should be enough. Let's go to all the remaining routers and enable that. Router OSPF1, segment routing MPLS. Same thing on R4, router OSPF1, segment routing MPLS. And then XZ router 3. And the last router is going to be XZ router 2. So segment routing MPLS. Now, one thing that you should keep in mind that that if this was ISIs, then I would need to do a few more things. So if this was ISIs as the IGP, then besides globally enabling segment routing MPLS and defining the prefix SID, you would have to go to, under ISIs, again enable segment routing MPLS, but you would also have to do metric style wide, which is required for segment routing. So your metric style should be wide if you're using ISIs. Let's now go to XR router and let's configure segment routing for XR, for ISP2. Now ISP2 was running ISIs. So let's go to XR1. We have, if you look at the diagram, we have XR1, 2, 3, 4, 5. Let's enable segment routing for, let's start with XR1. So step number 1 is going to be to enable segment routing. So like how we did in iOS XZ, we had to globally enable it. Here we don't have to really do that. We directly go to router ISIS1, go to address family IPv4 and say metric style as wide, and then you would say segment routing MPLS. Let's also go to define my prefix SID. That's going to be done under my loopback, but under router ISIS. So exit out and say interface loopback 0, address family IP. So address family IPv4, and here I would say prefix SID. Again, I can set index value or I could do an absolute. Let's set an absolute value. So absolute as 16031. I believe it is in that format. So 16003x, where x is the router number. So XR1 would be 1, 16031. And let's do commit. So if I do a show run router ISIS, you would see that globally under address family IPv4 under ISIS, I've done metric style wide for IPv4 and segment routing MPLS, and under my loopback under address family, I define the prefix SID. Again, if you want it for IPv6, you'll have to do the same thing for IPv6. Go under address family IPv6 and say metric style wide, segment routing MPLS, and then under address family, under the loopback, you would again define the prefix id, which again can be unique. It can be different from IPv4. Let's do the same thing on the remaining routers. So let's go to XR router 2. I believe on XR1 I did do commit. Okay, so XR2, again, router ISIS1, address family IPv4, metric style wide, and segment routing MPLS, and then interface loopback 0, address family IPv4, and prefixed absolute would be 16032. Let's do a commit. Let's do the same thing for XR3. Router ISIS1, address family IPv4, and metric style wide, and segment routing MPLS. Let's now go to my loopback and define my prefix id. So address family IPv4, prefix id absolute would be 16033, and let's do a commit. XR4, router ISIS1, address family IPv4, metric style wide, and segment routing MPLS, interface loopback 0, address family IPv4, and prefix id absolute 16034, commit. And the last XR router is going to be XR5. Again, here we would say metric style wide, and segment routing MPLS, interface loopback 0, address family IPv4, and then prefixed absolute 16035. So all you have to do is ensure that your prefixed value is unique. Your adjacency SID can be really, it doesn't need to be unique, but your prefix SID has to be unique. So once I've done this, if you do want to change your global block, you can change that also. So maybe I can go to my global outside, like segment routing, and hit enter. And here I could give the command global block. Let's say if I did want to change my global block from the default, if you remember the default was 16,000 to 23,999. So if I do want to change my global block, I can change it here. You should keep your global block the same across all the routers. I mean, it can be different, but you should keep it same again from, it just gets easier to troubleshoot. But you don't really need to change the global block. You can just leave it as default. So as per Cisco, it is 16,000 to 2399, which is basically reserved for segment routing global block. So I could make changes here, which I am not going to be doing. Let's go back and do a question mark. Let's exit out. So I believe my, let's say no. So if I do a show run router ISIS, you would see that segment routing has been enabled. And now we can go and test this. So do you think at this point of time, let's say if I do a show, let's do a show ISIS, show ISIS, segment routing, connected SID. So let's do segment routing, prefix SID map, and let's do question mark, active policy. So I see ISIS1 has an active policy. Let's in fact go to XZ router and try the command show ISIS segment routing connected SID. So, well, in fact, we don't have ISIS. Show OSPF, show IP OSPF, segment routing, and then let's do hit enter. Let's look at local prefix. So I see 2.2.2.2. The SID is 2 because I gave 16,002 as an absolute value, which is the index 2. Let's in fact try one more command. Show segment routing, MPLS, connected prefix SID map, IPv4. Here I should see I have the prefix SID for 2, which is 2, 4, 5, and 6. So all my SID indexes for all nodes will appear here, and I'm using OSPF, which is the source. So basically my signaling is, if you look at MPLS, signaling is done through LDP, but here my signaling was done through OSPF using opaque LSAs. So if I actually look at maybe my OSPF database, I should see an opaque LSA. Let's do a show. Let's do a show IP OSPF database. Show IP OSPF database. And look at opaque AS, or in fact we can just do show IP OSPF database. You see opaque LSAs here, which is type 10, so link states. So it uses basically opaque LSAs for exchanging those values or the SID values, which in MPLS was done through LDP. But here it uses OSPF. Let's also look at XR1. Maybe we can check this with show ISIS, segment routing, label table. We should get the labels, which was the SID values. So I see it here, 16031, 16032, 432, and 16033, 44, and 16035. So I see all the labels. Now the best part is, if you remember, I told you earlier that let's say if you're doing a migration, you don't need to remove MPLS. You can let segment routing be. It's not going to do anything. For example, right now, if I do a show MPLS forwarding table, you would see that I do have segment routing being used here, and I see those label stacks that you can see here. I see some of them, but let me show you XZ router. So if I show you XZ and do a show MPLS forwarding table, again here I see 16004, 16005, and 16006. I see M here, which indicates merged. Basically, MPLS, LDP, and segment routing is merged together as of right now, but it is still going to be using the LDP labels to reach the remote P. Let's in fact do a trace route. So trace route to 6666. Let's see which one is he going to be using. I see label 3004, which was my LDP label, and then 4004, and then 46.6, which is router 6. So it basically went from router 2 to router 3, From router 3, it went to router 4. So show OSPF, let's do a show IP route OSPF. To reach 6666, it is right now going to 34.4, which is upstream, and not going directly down to router 6. Let's do a show IP interface brief. And let's also do a show IP OSPF neighbor. I believe I have all my neighbors. Now the thing is that if you want to actually verify that which label is being imposed, like from an ECMP mechanism perspective, you can give the command show ceph, let's say 35.35.35.35/32. So XR1 is looking at the ceph for XR5's loopback. So if I do show ceph, you would see which label is being imposed. So here you should see remote adjacency to XR3, and my label imposed is 33003. Now if you remember, this is the label which came from LDP, which was the label that we gave for segment routing. It was, the prefix said was 16031 for XR1, 16032, 33, 34, and 16035. But I see 33003 because we haven't really given the command which says prefer segment routing over LDP. So let's go and now make segment routing the preferred control plane over LDP. So that's going to be done on iOS XZ. That's going to be done by going to config T, then going to segment routing, MPLS, and here you would say set attributes, address family IPv4, and SR label preferred. Let's do a show run section segment routing. So section, and let's copy this onto all the XZ routers. And then we have router 4, router 5, and router 6. So now if I go back to router 2 and do a show MPLS forwarding table, so to reach 6666, I should be using 16006. If you remember earlier, when I did a show MPLS forwarding table, let's in fact scroll back up. When I did a show MPLS forwarding table, it kind of looked different. It showed M, which basically says merged. So the label 3004 was being used to reach 666, and this label range was from LDP. But if I look now, I don't see that merged. Only segment routing is being used, and to reach 6666, it is using 16006. So if I do a trace route now to 6.6.6.6, look at the label stack. So this should be my SID list, which basically says go to router 3 but go to router 6 by going through router 4. So my label stack is 16006. And if I look at router 4, let's look at router 4, show MPLS forwarding table. To reach 6666, do a pop label The incoming label was 16006, which was the global SID value for router 6. Now, if you want to do the same thing on XR1, again, XR1 is preferring MPLS right now. For example, if I do, let's do a show IP route, or show route ISIS to reach 35, 35, 35, 35, it's going to XR3, which is the central router. If you look at the diagram, it is going through XR3 to reach XR5. And right now, if I do a show MPLS forwarding table, you would see show MPLS forwarding table. You would see that to reach 35, 35, 35, 35, it is going to use the label 33003, which is the LDP label stack, which is my LDP. It's not using segment routing. It is not using that at this point of time. But if I do want to use that, what I can do is go to router ISIS1, address family IPv4, and say segment routing MPLS, segment routing preferred. Let's do a commit, and let's copy this on all the remaining routers. So this should be here. So XZ router 2, router ISIS1, and commit. XZ router 3, router ISIS1, and segment routing preferred, commit. Then XR router 4, router ISIS1, segment routing preferred, let's do a commit. And then XR5, router ISIS1, segment routing preferred. So if I go back to XR1 now and give the command show Ceph 35, 35, 35, 35. If you remember earlier, the label imposed was LDP label, which was 33 or 350033, something like that. But if I see now the label imposed is 16035, which is my segment routing SID label or SID value. And if I do a show MPLS forwarding table, I am now using segment routing to reach 35, 35, 35, 35. I would be using the prefixed 16035. Let's in fact do a trace route to 35, 35, 35, 35. I should see 16035, which I am. So now segment routing has been configured and it is being preferred over MPLS or LDP. In fact, you shouldn't say MPLS because segment routing again is control plane for MPLS. So it's basically segment routing is now being preferred over LDP. So with this, we basically configured all of the requirements of the task. We would be doing some advanced segment routing in upcoming videos going ahead after we configure L3 VPNs. But right now we've completed this requirement and this task. I hope this video was informative to you, and thank you for watching.